Now let's look at these key databases and a little bit about how they relate to each other. Okay, we'll start with the RIB. The RIB is basically our routing table on a Cisco router, okay? Now this gets populated by various static routes we might add, connected routes, routes we learn from any of the different IGPs, or routes that we learn from BGP. Of course we use show IP route to take a look at the RIB. The RIB is a control plane concept. Okay, it determines how things happen, not really what is happening when it's forwarded. Okay, then we've got, in conjunction with the RIB, we've got the FIB. This is sort of the data plane side of IP forwarding. So the control plane side, we learned about all these routes and next hops through the RIB, and now we're basically putting that information into the FIB, the hardware database, really working with the Ceph table to determine, okay, what do we do when we actually get a packet? What database do we look in to determine how to forward it? That's the FIB. Okay, this is what's used to actually forward IP packets. It's created by Ceph, or Cisco Express Forwarding, on modern routers, and it's used in conjunction with something called the Ceph adjacency table. Ceph adjacency table is going to have sort of prepackaged layer 2 information that's used for forwarding. Things like, what's the MAC address of the next hop? What's the DELSI of the next hop? Things like that. Okay? So it's going to contain, in the FIB, information we need to forward IP packets. Well, what information? How about the IP next hop, outgoing interface, and stuff from that Ceph adjacency table? So again, the FIB is the data plane construct for forwarding IP packets. Now, if we get an IP packet and we need to forward it into an MPLS network, like PE1 in the previous example, the FIB can also instruct the router to push that label stack, that MPLS label stack, and send it into the MPLS network. How do we see the FIB? Show IP Ceph. Now let's move to the MPLS forwarding side, where again we have the lib in the control plane, but the LFIB in the data plane. Okay, we'll start with the lib. The label information base is basically a database that stores any kind of label related information. Okay? Not all that information will be put into the LFIB, similarly to like with maybe EIGRP, right? We have the topology table that we learn all this different routing information, but only the best stuff from the topology table goes into the routing table. Similarly, the lib stores all the labels, and then eventually some of those get into the LFIB. Okay, so again, the lib is storing all the label related information. The way this works is that the MPLS router, any kind of LSR, when it runs MPLS, it's going to generate a local label for every single connected route, static route, or IGP learned route, okay, that's in the routing table. So we generate a label, and then we advertise those labels to all of our neighbors using some sort of protocol. For our purposes, that protocol is going to be LDP, or the Label Distribution Protocol. So in other words, we generate all these labels, and we send those label prefix bindings to our neighbors. Okay? Then the LSRs, they're going to use their local routing table, IGPs, and all the information in the lib to determine which one to use, which one is the best. So in other words, if you want to think about it this way, with basic MPLS unicast forwarding, the IGP, or the routing table, is really still determining the best path, and it's used to determine which labels we're going to use to construct that end-to-end LSP. We can see this database by looking at show MPLS LDP bindings. Okay, and that's going to show us all the locally generated prefix to label bindings and the ones that we learned through LDP. Okay, now it is possible to also learn about labels through BGP. We're not really going to get into that in this class. with also another one is RSVP. But really we're going to focus mostly on LDP. And then finally we've got the LFIB. This is the hardware-based database that we use to forward MPLS packets. Okay, now this is actually constructed by the RIB, the LIB, and the FIB. So all those different things relate to the LFIB. Basically what happens is the router looks in its routing table, the RIB, right, for a particular prefix. And it looks at what's the next hop of that prefix. Then we're going to look and see, do we have an LDP neighbor with that next hop? Okay. If we do have an LDP neighbor for the next hop of the IP route, then we can look in the lib, the label information base, and we can say, okay, is there a label bound to that same prefix from that particular LDP neighbor? If it is, then we can take that label we learned from that particular neighbor and put it into the LFIB. We look at the LFIB with show MPLS forwarding table. Okay, so again, on the IP forwarding side, the control plane that is sort of the mastermind that determines all this is the routing table, the RIB. The hardware portion of it that determines what we actually do is the FIB. On the MPLS side, we build the lib by creating labels for our directly connected static and IGP learned routes, and by label and prefix bindings we learn from LDP. And then what goes into the LFIB is the data plane portion that determines how we actually forward stuff. That's going to be built by the RIB, the LIB, and the FIB, and it's really going to determine how we handle the MPLS packets themselves.